time. So this time around, so if you want to go see the screen, go to YouTube and you'll be able to see it. You can either follow the link in my profile to go to YouTube, or go to YouTube and type the Jack Studio. Vanessa, welcome. Josh, welcome. Gianna, welcome. So we're gonna do the same, not the same exercise, but a similar exercise to what we did last time. And then I'll sit around and if you guys have questions, I'll answer them. And if you want me to talk about something else, we can take them down. So that way, next time we go live, we can talk about it. For a while, no problem. Payne been watching the videos for a while, no problem. Well, thank you. I appreciate your help. I appreciate you. You following. I hope I help you too in those videos. Thank you. Thank you, Payne. Welcome. Is it book? I want to say Bucaro, but I don't want to mess up your name. So if you're on YouTube and you're not able to see the screen, let me know. Because I don't know what happened last time. I messed up and the screen wasn't showing at all. Matter of fact, let me go check. Actually, let me go check on Facebook to see if this. Let me go check if the screen is showing the way it's supposed to. Because last time it didn't show at all. Let's see. I think it's showing now. I think it is showing. So, it should be showing now on Facebook. So I don't know what happened last time. It just wasn't showing at all. And yeah, now it's good. Okay, so I double check. You guys, it's good. So if you want to see the screen, go to YouTube. What we're going to talk about today is something that we see a lot in if you take in algebra 1, algebra 2 actually, pre-calculus or calculus, maybe not calculus, pre-calculus, and they will give you those questions the exact same way that I'm about to show them to you. And they will give you those questions the exact same way that I'm about to show them to you, and they're going to ask you to find a bunch of answers. If you know how to do it exactly the same way I'm going to show you now, it's going to take you a few minutes to do it. But if you don't, it's going to take you a while, and you're going to have to, fight through it and find the best way to do it. So here's how it works. And then, as you can see on the screen, they give you a graph and then they ask you a bunch of questions. They ask you to find the domain, find the range, find if the function is symmetric about the origin or any axis, and they ask you if it's an even and odd function. They ask you if there is an intercept. So if there is a y-intercept or x-intercept, they ask you what those are. We're going to do this pretty quick. So now what we have here is this function right here. As you can see in the graph, we have this function right here. This is the function that we have. You see in the graph, you see the graph of the function. Now, the first thing that we're going to find is the domain and range. The domain of the function is, like I was saying last time, is the possible x values. So those are the values that you can put inside of the function and get an output for it. So sometimes when you have functions, you may have values that don't have any output. You may have input that doesn't match, that you can't just plug in inside a function, or where the output is undefined. So depending on the function that you have, you may not have an output for certain input. The way that I like to explain that to you guys, normally what I would say is saying that think about if you have an oven and there are certain things that you can put. Now in the realm of possibility, what I'm saying here is we don't want to mess up the house. We don't want to blow up the house or start causing a fire. There are certain things that you can put inside of this oven that doesn't cause a fire, and there are other things that you cannot put in there. So let's say if you try to put maybe aluminum foil or a paper in there. So you can't just put a paper in there, but you can put chicken, you can put dough, you can put cake, you can put all those. So those are those possible input. What are the possible output? Possible outputs are Carino. Hey, how you doing? Possible outputs are cooked chicken, a fully baked cake, or some burnt food too, if you don't know how to cook well. So now, if you go to YouTube, you'll be able to see the screen, the exact same thing that I'm explaining to you right now. So if you're not on YouTube, it will be kind of hard for you to follow. So I would go to YouTube. You can go to the profile and then click on the YouTube. Click on the YouTube, you'll see it. All right, good. So let's find the domain of this function. As you can see the graph of the function. The domain, we say it as possible x values. So if we go so from left all the way to the left, and from all the way to the left, negative infinity, and all the way to the right, we have infinity. So all the way right here, and then we assume that the function continues all the way to the left and also continues all the way to the right. So it continues on this in this direction and also continue in that direction. Now, as you can see here on the left, from all the way to the left and all the way to the right, the value, that function, that specific function has can take all of those values. That specific function here can take all those values from the left, from negative infinity and all the way to positive infinity. It can take all those values. So what we see here in this case is the function is, the domain of the function, the domain of this function is, you could say all possible values of r, or you could say, you can just write it in terms of intervals, negative infinity to infinity. Now, that's the domain. This is all you did. So all we did is we look at the graph and see all of the possible x values. In this case, in that specific case, the value, the possible x, the function can take all possible x values. So that means the domain is negative infinity to positive infinity. Now, let's look at the range. So if for domain, we went from left to right, for range, we're going to go up and down. So we're going to go up and down. Now we're going to see all the possible, what are the possible y values that this can take? And in terms of the oven is, what are the possible things that can come out of the oven if we start putting stuff in it? So now let's see what are possible y values. Now, if you can, as you can see here on this graph, it looks like it start going, so up and down. And let me erase some of these. So actually, let me erase some of these so you can understand what I'm saying. So if we go up and down, let me use a different color for no reason at all too. If we're going up and down, what we can see is the function only is in this range, this little range right here. So from here to here. So the values are, so those are all the possible x values the function can take. Like if we have 5 here, the function cannot take a y value of 5, cannot give you a y value of 5. It's same for -5, the value of the function doesn't reach -5. But where does it cut off at? What does it cut off at in that range, in that possible range of values? What does it cut off at? It cuts off in it cuts off it cuts off right here in between. It cuts off between positive 1.5, and you can see this is between 1 and 2, 1.5, and then here it cuts. It's tailored here at, it flats out at -1.5 at the bottom. So what we're saying here is the possible y values in this function, the possible y values are -1.5 and 1.5. So that's the range of this function, -1.5 all the way to 1.5. And if you, the only way to see the screen is go to YouTube, -1.5 and all the way to 1.5. These are the possible y values. Now, okay, we found the domain, we found the range. Now we're going to find the x-intercept. So like I was saying last time, the x-intercept is on a graphing calculator, could you use the 0 option to find which one? The 0 option to find which one? So which questions are you referring to, Payne? So I don't know if you're referring to the domain, the range, or the x and y intercept. So now, yeah, you can use those functions. So that means the x-intercept is no, domain and range. The only way you'll find it in the calculator, you could probably graph it and see the domain and range, but they already give you the graph. So in this case, you just look at it, it's visual. And in a calculator, when you can actually solve this function and set it, if you had the equation, you can set it equal to 0 and find, the values where you would set all the y values equal to 0. So you'd find the values where, what do you call those? So you said y equal to 0, that means f of x is equal to 0, and you'll find, in this case, it could be 2 points x, so you would find a value of maybe 5, 0. This is not the case for this one, but it would give you 0, 0 in this case. So that would means the the x-intercept. That means the y value is equal to 0. So now, that brings me to the point that I was making. So when we're calculating the x-intercept, so that means this is where the function intercept the x-axis. That means the y value in this case is equal to 0. What about the y-intercept? The same thing for y-intercepts, vice versa. This is where the function intercept the y-axis. That means the x value is equal to 0. And that makes sense too, right? So if I have a function that cuts the y-axis here at 4, there's no x value for that 4, because x is equal to 0 and y is equal to 4. So that means, visually it makes sense. Now, how do we do that in the graph? How do we do that in the graph? Let me go in a different page and find the x and y intercept. Let me put the graph back on there. So let's find the x and y intercept. So, nope. So x-intercept. So when we look at the function here, all we see is, okay, there's the function, the curves goes this way, and then it gets here, and then it flats out that way. So where the function crosses the x and the y axis at the point 0, 0. So what does that mean? This is a very interesting case. So what does that mean? That means when x is equal to 0, y is equal to 0. So that also means that the x-intercept, one of the x-intercept at least, is x, the function intercept the x-axis at, and then the x-intercept, in this case, x is equal to 0, and also y-intercept, y is equal to 0. So the function crosses the x-axis and the right and the y-axis at the point 0, 0. So x-intercept and y-intercept both equal to 0. Now, we're good on this one. So that means we found the domain, we found the range, and we also found the x-intercept and y-intercept. Let's do the other question that they ask us. They say the interval for which the function is increasing. Now, what does that mean the function is increasing? So what does that really mean? It sounds, it's the same way as it sounds. The function is going up and up. What interval in which the function is going up and up, and what's interval in which the function is going down and down? So let's put the graph back in, and we're going to do that many times so that way we don't mess up our work that we've done. So let's put not this. Actually, I wanted the graph. So let's put the graph back in. Let's put the graph back in there. How do we find the where the function is increasing? To find where the function is increasing, just like the name and tell, this is the function. This is the area which, the interval which, as you're increasing the x values, as you're going up and up in x value, the value of y is going up and up. And the same thing similar to decreasing. If the function is decreasing, as you're going up and up in x value, the value of y was going down. And the function is constant. As you're going up and up, or you're moving to the right, the value of x stays the same. So how do we find that? How do we find where the function is increasing? So the function here is increasing at what values is the function increasing? So it's from here, from negative infinity to infinity. So what do we see? From negative infinity here, we were at negative 1.5 as we saw in the range, and it goes to start going up and up. It gets to 0, which is greater than negative 1.5, and it goes all the way up to 1.5. So from negative infinity, as I'm going from left to right in x values, so as I'm increasing the x values, the value of y, the y values are also increasing. So that means in the whole entire range, the function is increasing. So where's the interval from which the function is increasing? From negative infinity to infinity. So from that whole interval, the function keeps going up and up. So that means if I plug in an x value of 17, and then I plug that into the function, the y value, I'm going to get a y value. But if I plug in an x value of 300, I'm going to get a y value that's even greater than that. So you can do this in each one of those little pieces of intervals. So now what in this case, we're saying the function is increasing from negative infinity to positive infinity. Now, so if it's decreasing, and I mean increasing in the whole interval, in the whole range in R, so what does that really mean? That means it doesn't decrease at all. It doesn't go, there's not a time where the function is going down to so there's not a time. No problem. I'm glad to help you. There's not a time that the function is going down. There's not a time that the function is going down. There's not an interval from which the function is going down. The same thing we're saying too. If it's so, that means it's not decreasing. No. And also constant, the function is not constant because we just saw that from this whole interval, from the interval of negative infinity all the way to infinity, the function keeps going up. So that means the function doesn't go down or it's not constant at all in that whole interval. So that means it's not constant. Now that knocks out question, letter D, E, and F, because all we found was the function is increasing from the interval of negative infinity all the way to infinity. Now, here's a much more interesting questions. A lot of time they ask if the function is symmetrical about the x-axis, the y-axis, or the origin. And now, this may sound like it's something that's tough, or it may sound like it's something that's hard to understand, but it really isn't. Alina, welcome. It really isn't something that's hard to understand. So symmetric means if we consider the point of reference, if we consider the point of reference that they tell us, so it's kind of like you're going to have a mirror image of each other. So like whatever is to the left of that point of reference and whatever is to the right of it is going to look the same. Or if the point of reference is something horizontal too, up and down is going to be looking the same. So now when we look at this function right here, and I'll put the graph again in a new page so that way we don't mess up our work, if we did any work at all. So now, when we look at this function right here, and I'm going to change color for no reason at all. When we look at this function right here, and if we consider this origin right here, and let's make it as if let's say, let's think about it this way. Let's say that we didn't know if it was symmetric around the origin, and as you can see here around the origin, whatever is this way and whatever is that way, they look exactly the same. Let's say that we didn't know. We were trying to see if it's symmetric around the y-axis. For it to be symmetric around the right, about the y-axis, whatever is to the, if we consider the y-axis, whatever is on this side would be the exact same thing of whatever is on this side. And that's not the case here. And the same thing for x-axis. If it was symmetric about the x-axis, whatever is up here above the x-axis would be the same as whatever is below the x-axis. So that's what it means for symmetric about whatever the point of reference that you're saying. So to the left and of it, to the right of it would be the exact same thing. And in this case, it's not, it's not the same for x and y-axis. So what do we have left is the origin. And if you see about origin, whatever is on this side of the origin and whatever is on this way look exactly the same. So what we say is the function is symmetric about the origin. And that's it. Let me see what other question that they ask. So the other question that they ask us is, so we say this is symmetric about the origin. The other questions that they ask, which is the last question, very interesting question too, whether the function is even or odd. Now, there are many ways to find this out. So if we want to know the function is even or odd, mathematically, what does that mean? It means that if the function is even, f of, and I'm going to explain that to you. If the function is even, f of, so for x value, for any x value, f of, for all x values, f of x is equal to f of negative x is the same as f of x for all x values. So what does that really mean in terms of, in terms of representation? So that means f of 2 is the same thing as f of negative 2. F of 3 is the same thing as f of negative 3. And in graphically, what is that going to look like is what you're going to have to the left is going to be the same thing that you're going to have to the right. So graphically, here's what that looks like. So whatever is look to the left, so f of negative 2, if I have negative 2 here, it goes all the way, let's say that goes to 4. Same thing to the right, f of positive 2, and I put positive here so you can understand what I'm saying, is going to go all the way up to 4. So both of these going to go to 4, and it's the same thing for negative 1, negative 15, negative 20, and positive 20. So that would mean the function is symmetric about the it would be an even function. Now the function is, if the function is odd, if it's an odd function, so what does that mean? An odd function means f of, and I want you to pay attention to this, f of, if the function is odd, f of negative x is equal to negative f of x. So what is that? What am I saying here is that f of negative 3 is equal to negative f of 3. And I'm going to put some numbers so you can understand what I'm saying. This is for any x values that's part of the domain, of course. So we're speaking in terms of, the x values that are part of the domain. F of negative 3 is equal to negative f of 3. So if f of negative 3 was 9, f of 3 would be the negative of that. So that would be negative 9. So if f of, so what are we saying? It's saying that whatever value that I have here, so if I have for any x value, f of negative x is negative f of x. So how do we find, so let's say f of 3 was 9, f of negative 3 would be the negative of 9, which is negative 9. Okay, so now let's look at this function and see what we have exactly. Let's look at this function, and I'm going to put it back on the screen. Nope, that's this one. That's not the one that I want to look. We looked at this last time. So let's look at this function. What is f of negative 2? Negative 2, f of negative 2, it goes to a value of, let's say this is negative 1.2. Negative 1.2. F of 2 goes to what value? 1.2. Same thing. F of negative 5. Let's say this is negative 1.4. And I'm speculating here, but I don't know if it's exactly that, but it's close to it. F of negative 5. Let's say this was negative 1.4. F of 5 is 1.4. And it continues that way. So what we found here is f of negative x is equal to negative f of x. So what the same thing that we saying, f of, so f of let's say 1.4 here, f of 5 is equal to what? 1.4, as we just saw, as I just showed you. I mean, it's not exactly that, but it's very close to 1.4, we say. F of 5 is 1.4. What is f of negative 5? Without even looking at the function, that would be the negative of that, negative 1.4. So that means the function is odd. And it's not an even function. That means the function is odd. And it turns out, because the function is, symmetric about the origin, that means it's an odd function. And if it was symmetric about the y-axis, we would have an even function. Now, that's all we have. That's all we have for today. And let me recap. So the first thing that we did today was we found the domain and range of this function. We found the domain, the range. And then we went on into the intercept, saying that, okay, the x-intercept of this function is this. The y-intercept of this function, this is how you find it. And then after that, when we found domain, range, x-intercept, y-intercept, we found we also went into let me see what other questions that they asked us. We also went into um, we found the function, the intervals for which the function is increasing and decreasing. And after that, we saw if the function was or symmetric around the origin or the y-axis or the x-axis. And then the last thing that we did, we found if the function was even and odd. This exact same question, I'll tell you, if you're taking algebra 2, you will find something exactly like that. And that's not one question, but it's going to be many questions exactly like this. If you study in function in algebra 2, that comes up in exams and anything, you'll find many questions exactly like this. So if you want to see the screen, the best thing to do is go to youtube.com and then type on the search bar, type the Jax Tutor. And I think this is it. So Sydney, welcome. Marshall, welcome. Lexi, welcome. VMF, welcome. All right, guys. Is it Anzer? I don't want to mess up your name. Welcome. So that's it. That's all we did for today. And if you have any questions or anything, let me know. If not, I think this is it. This is all we're gonna do for today. And I'll catch you guys another time. I hope. I just realized this whole time, actually, this is not streaming using the what I wanted to use. So I hope this was clear, and I think I did my best to try to explain it to you. I hope this was clear to you guys, and thank you guys for coming by. I will catch you all another time. Thank you. This was Romel with the Jax Tutor. Welcome, Pretty Field. Welcome, and for all of you who just joined, if you want to see exactly what we just did, go to YouTube and type the Jax Tutor, and you'll see all of it. Thanks a lot. Bye.